If you were to stack Mount Everest upside down into the ocean, its peak still wouldn't reach the bottom of the Mariana Trench. At nearly 11 kilometers deep, it is the most extreme environment on Earth. Pitch black, freezing cold, and under pressure so immense it would crush a submarine like a soda can. For decades, people assumed little to nothing could survive down there. But in recent years, expeditions have pulled back the curtain on this hidden world. And what they've found is stranger than anyone expected. Entire colonies of life that don't need sunlight at all. Creatures adapted to pressures 1,000 times greater than at sea level. Microbes that thrive on chemicals leaking from the earth itself. And in the middle of it all, evidence of us, from plastic bags to mysterious sounds that once fooled scientists into thinking they'd found something alien. The deepest place on Earth isn't just an abyss. It's a window into how life can bend the rules, and a warning about how far our impact has already reached. Imagine dropping a stone into the ocean and waiting to hear it hit the bottom. In the case of the Mariana Trench, you'd be waiting a long time. Located in the western Pacific Ocean, east of the Philippines and south of Japan, the trench is nearly 2,550 kilometers long, about the distance from Los Angeles to Dallas, and plunges deeper than any other known part of the seafloor. Its most extreme point, Challenger Deep, sinks to around 10,920 to 10,984 meters, depending on the survey. To put that in perspective, if you could place Mount Everest inside the trench, the peak would still sit more than 2 kilometers below the surface. This abyss is not just a deep hole in the seafloor. It's a geological scar carved by the collision of tectonic plates. The Pacific Plate is sliding beneath the smaller Mariana Plate in a process called subduction, which creates the trench and drives earthquakes and volcanic activity in the region. It's a reminder that Earth's surface is constantly in motion, reshaping itself over millions of years. Conditions at the bottom of Challenger Deep are so extreme that they sound almost uninhabitable. Temperatures hover just above freezing. There is no natural light, and the pressure reaches over 1,000 times what we experience at sea level. That's equivalent to the weight of an entire African elephant, pressing down on every square inch of your body. For much of the 20th century, scientists assumed life here would be sparse, maybe even non-existent. The logic was simple. No sunlight means no photosynthesis, and no photosynthesis means no food web. Yet the trench has always held a magnetic pull for explorers. The first serious attempt to reach Challenger Deep came in 1960, when Jacques Piccard and U.S. Navy Lieutenant Don Walsh descended in the bathyscaphe Trieste. Their steel sphere, barely large enough for 2 people, withstood the crushing pressure and reached the bottom after a nearly 5-hour descent. Through their tiny window, they reported seeing flatfish and shrimp-like creatures, though later researchers debated whether those sightings were accurate. Regardless, the dive proved that humans could reach the deepest point on Earth. After that, the trench remained largely untouched for decades, too expensive and dangerous for regular visits. It wasn't until filmmaker James Cameron's 2012 solo dive in the deep-sea Challenger that public attention swung back to the abyss. His journey brought back high-definition footage and samples, but perhaps more importantly, it reignited curiosity about what might live down there. Since then, new submersibles, robotic probes, and deep-sea landers have made it possible to explore these depths more systematically. Every mission to the trench begins with a sense of stepping into the unknown. Unlike the surface of Mars, which we've mapped in great detail, less than 20% of Earth's ocean floor has been thoroughly mapped. The Hadal Zone, depths below 6,000 meters, is the least understood of all. These regions are not just deep, they're alien in every sense, separated from the rest of Earth's ecosystems by pressure, darkness, and cold. They form a frontier that tests the limits of life and technology alike. The Mariana Trench, then, is more than just a geographical record breaker. It's it's a natural laboratory for asking fundamental questions. How does life adapt to extremes? What role do these deep environments play in Earth's systems? And perhaps most pressing, how far has human influence reached, even here? The answers, as researchers are now discovering, are reshaping how we think about our planet's most hidden places. When scientists finally began probing the Hadal Zone in earnest, they expected to find only a few scattered organisms, barely scraping by on the trickle of organic material sinking from above. Instead, they uncovered ecosystems that were not just surviving, but thriving. One of the most striking findings came from the MEER project, an international collaboration that analyzed sediments and microbial communities in the Mariana Trench. Researchers reported that more than 7,500 new microbial species were cataloged, and nearly 90% of them had never been described before. Many of these microbes use unique metabolic pathways to extract energy from chemicals like ammonia, methane, and sulfur compounds, processes that are completely independent of sunlight. This discovery overturned the long-held assumption that deep ocean ecosystems were almost barren. In reality, they harbor staggering genetic diversity, much of which could be key to understanding life in extreme environments. Macrofauna, larger, more complex animals, have also proven more abundant than anyone expected. Amphipods, shrimp-like crustaceans, are everywhere in the trench, swarming around baited cameras. These creatures have adapted to withstand crushing pressures that would rupture most cells, partly by producing unique molecules called piezolites, which help stabilize proteins and membranes under stress. Scientists have even found amphipods carrying high levels of pollutants like PCBs and microplastics, proving that human contamination has reached even the Hadal depths. Beyond amphipods, entire communities of worms, mollusks, and other animals have been discovered clustered in places where chemicals seep out of the seafloor. In 2024, Chinese submersibles recorded scenes straight out of science fiction. Blood-red tube worms swaying like underwater forests, translucent snails glinting with an iridescent sheen, and pale, bristly worms carpeting the mud. These animals don't rely on sunlight at all. Instead, they live in partnership with chemosynthetic microbes that turn chemicals into food. The discovery of such densely packed life nearly 6 miles below the surface has been described as one of the deepest and most complex ecosystems ever recorded. These findings matter far beyond biology textbooks. They suggest that extreme environments are not biological deserts, but cradles of innovation. The adaptations seen in these trench organisms, unique enzymes, pressure-resistant proteins, and unusual survival strategies could hold clues for biotechnology, medicine, and even the search for extraterrestrial life. After all, if microbes and animals can thrive in the freezing dark under 1,000 atmospheres of pressure, perhaps life could also survive in the subsurface oceans of Europa or Enceladus. The picture that emerges from the Hadal Zone is not one of scarcity, but of resilience. Far from being empty, these depths are bustling with forms of life that push the boundaries of biology. And with every expedition, the list of discoveries grows longer, hinting that we've only just scratched the surface of what lives in the deepest parts of our planet. Until recently, most scientists pictured the Hadal depths as lonely places where only a few scattered scavengers drifted between meals of sinking detritus. But discoveries in the Mariana Trench and other Hadal zones are rewriting that image. At the bottom of the Pacific, researchers have found the deepest cold seep ecosystem ever recorded, and it changes how we think about life on Earth. A cold seep is not what it sounds like. It isn't icy water leaking through cracks. Instead, it's a place where gases and fluids, often rich in methane and hydrogen sulfide, seep slowly out of the seafloor. These chemicals are toxic to most familiar forms of life, but in the dark trenches they become the foundation of entire ecosystems. Microbes living here use chemosynthesis, turning chemical energy into food in the same way plants use photosynthesis. Where gases bubble out of the mud, dense colonies of life gather, powered not by sunlight but by Earth's chemistry. In 2024, Chinese deep-sea explorers documented one of these communities nearly 6 miles down. They filmed bright red tube worms clustered like stands of coral, ghostly white clams packed shoulder to shoulder, and snail species with shimmering shells. All of these creatures rely on internal or external partnerships with chemosynthetic bacteria, essentially farming their own food supply. The tube worms, for example, don't even have a digestive tract. Instead, their bodies are filled with symbiotic microbes that process the seep chemicals into nutrients. Finding such a dense ecosystem, so far below the reach of sunlight, was a revelation. It confirmed that Earth has at least 2 separate biological energy systems, one driven by the sun at the surface, and another powered by geochemistry in the deep. This dual model broadens our view of what life needs to exist. On worlds like Jupiter's moon, Europa, or Saturn's moon, Enceladus, where sunlight can't penetrate thick ice crusts, chemical seeps at the ocean floor might fuel similar kinds of life. In a sense, the Mariana Trench has become a proxy for studying alien oceans without leaving Earth. What's even more surprising is how stable these communities can be. While surface ecosystems are vulnerable to storms, heat waves, and changing seasons, cold seep ecosystems draw their energy from slow, geological processes. Some could remain active for thousands of years, sustained by the slow leak of chemicals from Earth's crust. For scientists, this is both exciting and unsettling. On one hand, these ecosystems show us that life is more adaptable and inventive than we imagined. On the other, they highlight just how little we know about the seafloor. Each dive seems to reveal another world within our world, suggesting that the trench is less a barren pit and more a patchwork of hidden oases. And yet, even in these seemingly untouched strongholds, signs of our presence appear. Plastic fibers and pollutants have been detected in cold seep animals, raising urgent questions about how human activity is altering ecosystems that took millions of years to form. The discovery of the deepest cold seep communities forces us to rethink the limits of habitability. They prove that life doesn't need sunlight, only a steady source of energy, and that Earth's most alien habitats may be the best analogs for the search for life beyond our planet. For all the strange creatures and hidden ecosystems in the trench, perhaps the most jarring discoveries are the signs of ourselves. The Mariana Trench is about as far from human habitation as it's possible to get. Yet explorers continue to find evidence that our presence has reached even here. In 2022, oceanographer Dawn Wright joined explorer Victor Vescovo in a dive to Challenger Deep. Their submersible limiting factor is one of the only crewed vehicles capable of withstanding the crushing pressures of nearly 11,000 meters. Over the course of their descent, they pass through absolute darkness, descending for more than 4 hours before finally touching down. What they expected to find were the silent inhabitants of the abyss: amphipods, sea cucumbers, and anemones anchored in the mud. What they didn't expect was to see a beer bottle lying on the seafloor, stark evidence of pollution in a place that should be untouched. This was not an isolated case. Previous missions have reported plastic bags, candy wrappers, and even tangled fishing line caught in the trench. A robotic lander sent in 2019 filmed plastic debris more than 10,000 meters down. Scientists analyzing amphipods collected from the trench found that every single specimen had microplastic fibers inside its digestive system. These fibers are shed from synthetic fabrics, packaging, and discarded plastics that break down at the surface, then sink slowly into the deep ocean. Even in the world's most remote habitat, organisms are eating our waste. More troubling still, chemical pollutants have been detected in hadal fauna. Amphipods from the trench were found to contain PCBs, polychlorinated biphenyls, and PBDES, flame retardants. Toxic compounds banned decades ago, but still circulating in the environment. Because trenches act as sinks, collecting organic matter and debris from across the ocean, they also concentrate pollutants. This means that the deepest animals on Earth may actually be among the most contaminated. The human presence isn't limited to pollution, though. Our expeditions have also left a mark in the form of exploration itself. From Jacques Picard's pioneering dive in 1960 to James Cameron's 2012 solo journey, each mission has added to our knowledge, but also carried the risk of introducing disturbances. Modern submersibles minimize impact, but even so, the trench is no longer a place untouched by humanity. The paradox of Challenger Deep is that it is both one of the most inaccessible and one of the most vulnerable places on Earth. While we marvel at the life that manages to thrive under impossible conditions, we're also confronted with the reality that human activity has left fingerprints all the way to the bottom of the ocean. In a sense, every new discovery of life in the trench comes with a mirror image, proof of how far our influence extends, and a warning about how little of the planet remains truly isolated from us. For years, one of the strangest mysteries of the Mariana Trench wasn't something seen, but something heard. In 2014, oceanographers recording sounds in Challenger Deep picked up a bizarre, low-frequency noise unlike anything in their archives. The sound lasted only a few seconds, rising in pitch before dipping again, and was repeated in intervals throughout the year. It was eerie, almost musical, earning it nicknames like the Alien Song or Bio Twang. At first, researchers weren't sure what to make of it. The Mariana Trench is far from busy shipping lanes, so it wasn't likely to be mechanical noise. Some speculated it could be geological, the groaning of shifting tectonic plates. Others wondered whether it might be an unknown animal call, though it didn't match any catalog species. For a while, the Alien Song hovered in the tantalizing space between science and mystery, sparking public speculation about deep-sea monsters or even extraterrestrial communication. But as more recordings came in, a clearer picture formed. Acoustic analysis suggested the sound came from a biological source. An AI-assisted pattern matching eventually tied it to whales. Specifically, scientists concluded it was the call of the bride's whale, a baleen whale found in warm waters across the Pacific. Bride's whales use a range of vocalizations, many of them poorly documented, and this unusual bio-twang was simply one of their lesser-known calls. Far from being alien, it was a reminder of how much we still don't know about the everyday lives of ocean animals. The revelation was both anticlimactic and profound. On the one hand, the mystery turned out to be a whale song rather than an otherworldly phenomenon. On the other, it underscored how much of the deep ocean remains uncharted territory, even for species we share the planet with. The Mariana Trench amplified the strangeness of the call, bouncing sound waves through its cavernous walls, making them echo like voices from another world. This solved mystery is emblematic of trench exploration as a whole. Time and again, what first seems bizarre or inexplicable eventually reveals itself to be part of life's incredible adaptability. The trench doesn't need aliens to be mysterious. The organisms that live there and the ways they've adapted are already as strange and otherworldly as anything we could imagine. The Mariana Trench is often described as Earth's final frontier, and for good reason. Despite decades of exploration, we've mapped the surface of Mars in far greater detail than we've mapped the bottom of our own oceans. Challenger Deep remains one of the least understood places on the planet, yet each expedition adds another piece to the puzzle of how life and Earth systems function at their extremes. One of the most important lessons from trench exploration is how interconnected the planet truly is. What happens at the surface doesn't stay at the surface. Pollution, plastics, and chemicals eventually find their way into the deepest trenches. That means the Mariana Trench isn't just a geological oddity. It's a kind of environmental time capsule, storing evidence of human activity that might persist for centuries. The amphipods and worms living in the Hadal zone are not just remarkable survivors. They're unwilling witnesses to the global reach of pollution. At the same time, the trench offers extraordinary opportunities for science. Microbes adapted to high pressure and low temperature are already inspiring new research into enzymes that could be used in medicine or industry. The unique chemistry of cold seep ecosystems shows us that life can thrive without sunlight, broadening the scope of what we consider habitable environments. When astrobiologists look for life on icy moons like Europa or Enceladus, the trench serves as a natural analog. If life can exist here, perhaps it can exist there too. On a broader scale, the trench highlights just how little we know about our own planet. The Seabed 2030 project, a global effort to map the entire ocean floor by the end of this decade, aims to fill in those gaps. Every new survey reveals unexpected features: underwater mountains, landslides, and hidden ecosystems that reshape our understanding of Earth's geology and biology. The Mariana Trench is a crucial part of that story, reminding us that the world still holds places that are as alien to us as the surfaces of other planets. Yet there's also an urgency to this exploration. As interest in deep-sea mining grows, conservationists warn that fragile ecosystems could be destroyed before we even know they exist. The organisms of the trench have taken millions of years to adapt to their environment, and they may not recover if disrupted. Protecting these habitats requires recognizing their value, not just as curiosities, but as essential pieces of Earth's living system. In the end, what we've found in the deepest place on Earth is a mixture of wonder and warning. We've discovered thriving ecosystems that defy our assumptions about where life can exist, and we've uncovered evidence of our own far-reaching impact. The trench teaches us that Earth is both more resilient and more fragile than we imagined, capable of producing life under impossible conditions, yet vulnerable to human activity that spans the globe. Exploring Challenger Deep isn't just about solving mysteries of the ocean floor. It's about understanding the boundaries of life, our role in shaping the planet, and the possibility that the strangest places on Earth may also be the key to finding life elsewhere in the universe. The Mariana Trench reminds us that even in the most hostile corners of our planet, life finds a way, and that our actions reach farther than we ever imagined. From strange glowing snails to whale songs echoing like alien voices, the deepest place on Earth is full of stories waiting to be told. So here's a question for you. If this is what we've found in the small fraction of the trench we've explored, what might still be waiting in the darkness we haven't reached yet? If you want to keep uncovering the hidden corners of our world and beyond, make sure to subscribe, drop a comment with your theory about the next big deep-sea discovery, and share this video with someone who loves a good mystery.